Hello, in this video, which is just a repeat of what we did in the seminar, but since many of you spent a long time ago, since I did the seminar, I thought I'd just repeat it and put it on Schoology for you, is I want you to use the key features of functions to sketch the graphs of linear and nonlinear. Some key features are the x-intercept, where you cross the x-axis, the y-intercept, where the graph crosses the y-axis. When the graph is positive, that is when it's above the x-axis. When it's negative, that's when it's below the x-axis. When it's increasing, that means it's growing from left to right. Decreasing, it's falling from left to right. And the end behavior, which we talked about in the last lesson, how it approaches positive infinity and negative infinity. If we take a look at problem number 1, we want to use the key features to sketch a linear graph. First thing I want you to notice, it's linear, which means it's going to be a line. And we're told that the y-intercept is 2. So I'm going to graph, or I'm going to plot 2 on my y-axis. And then we're told that the function is positive for x is greater than negative 1. So I'm going to put a point on my x-axis at negative 1. I could stop right here because I'm told it's linear, and I'm told that it's positive at greater than negative 1. I could draw the line that goes through these points. And there is my linear graph. Let's continue reading it, just make sure we understand everything that's going on there. It says the function is increasing for all values of x. Notice the line I drew is always going up. As x approaches positive infinity, f of x approaches positive infinity. And as x approaches negative infinity, f of x approaches negative infinity. There's our graph. Pretty strong. On our next box, we have some vocabulary words. Continuity means the function is continuous. You can graph the line without picking up your pencil. If it's not continuous, then you have to pick up your pencil at some point to do it. Extrema we talked about in the last lesson. That's the maximum minimum values of your function. And then symmetry we also talked about in the last lesson. That is, there's reflectional symmetry. That means you have a vertical line you could draw through the graph, which would be the same on both sides. Now let's apply that to example number 2. We want to use the given features to sketch a nonlinear graph. Nonlinear means our graph is not going to be a line. So we have some curves in it. We're told the y-intercept is 1, so I'm going to put a point at 1 on my y-axis. I'm going to change that to my pen, though, first. So you have a point on your y-axis at 1. We know the function is positive between negative 1 and 3. So I'm going to put a point at negative 1. I'm going to put a point at 3. Next, we're told that the function has a maximum at 1 and 2. So at 1 and 2, I'm going to put a point at 1 and 2. The function is increasing for values less than 1. So I know it's increasing for values less than 1, and I know as x approaches positive infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. So what happens here, there's more than one correct answer, but I do know I'm going to, when I go to negative infinity, I'm going to be going down. And it could be going down in different areas. I know my graph is increasing. It's positive between negative 1 and positive 3, and it reaches a maximum value at 1 and 2. So I'm going to have it curve down there. And then we're told as x approaches positive infinity, f of x approaches negative infinity. So I know I'm just going to draw my graph going down in that direction, maybe more vertical. Change colors here so you can see it. So maybe I want to make sure I'm going to show that it's going down at that point. And Once again, there's more than one correct answer, but that's on question number 3, we're told the function is continuous, so I can draw it all as 1. And it's symmetric about the line x equals 1. So what I'm going to do is I'm going to use a light color. I'm going to draw a vertical line around 1. X equals 1. So whatever I do on the left, I'm going to do the same thing on the right. The function has a minimum at 1, 0. So I didn't need to draw my line all the way down because it can't get any lower than 1, 0. And I'm told as x approaches positive infinity, f of x approaches positive infinity, so I know it's growing as I go to the right. And as x approaches negative infinity, f of x approaches positive infinity. So in other words, I know it's growing in both directions. Kind of seems like it might be a parabola, huh? So that's what I'm going to draw. I have it's growing here, it's growing here. It's supposed to be symmetric. I didn't draw a very good line there for symmetric, but we get the idea. Pretty much that's what you do. On question number 4, we have a story we're going to tell through a graph. We want to use the key features for Leah going on a bike ride on a bike path near her house. We know the y-intercept is 0, so I'm going to put a point at 0. The function that models the situation is nonlinear, so it's not going to be a straight line. We know that much, but we know it's going to have some curves in it. We know Leah's maximum speed is 15 miles per hour, so I know her speed will never get bigger than 15. So what I'm going to do on the side here is I'm going to have speed on my side because that's my dependent variable. That color switched on me. And I know I have to go up to 15, so there are 20 tick marks, so I'm going to count by ones. And we know she reaches at 1 minute after she starts her trip. So she must leave home and probably going down a hill. We know her speed is increasing steadily for the first minute. Well, that makes sense from what we were told about the extrema. We know at the 10-minute mark, Leah decreased her speed for 1 minute. And then she stayed at 10 miles an hour for 5 minutes. At the 16-minute mark, she again decreased her speed for 1 minute until she reached the stop. In other words, her trip took 17 minutes. So my graph has to go up to 17. And so I'm going to put, this time I'm going to put time on my x-axis. I'm going to count up. Now that I've got my axis drawn in, I'm going to graph some of my points that I knew were going to be in there. So I know after 1 minute, Leah's speed is 15 miles per hour. So I'll put a point at 1 and 15. I know at the 10-minute mark, she decreased her speed for 1 minute, and then she stays at 10 miles an hour. So at the 16-minute mark, or I should say at the 11-minute mark, she's at 10 miles per hour. And then we're going to stay there at the 16-minute mark. At the 17-minute mark, we're back to 0. So now I got a lot of my key points, so now I'm just going to draw my line. And remember, don't make corners, make curves. So I know from 0 to 1 minute, she's going to go up to 15. Now it doesn't tell me what she does from there, but we do know at the 10-minute mark, she's going to decrease her speed. So I'm going to have her go at 15 miles per hour until we get to the 10-minute mark. I probably should put a point there for 10 so I know when to turn. And then I'm going to go down to the 11-minute mark to 10 miles per hour. And then we're going to go straight there. And then finally, we're going to curve home or turn home. And that's it. There's a story.